How to convert to hexadecimal. So what is hexadecimal? It's a base 16 numbering system, and the first 10 digits are like decimal, 0 through 9, but then these other 6 digits, 10 through 15, are written A, B, C, D, E, and F. And the reason why we do this is because writing a 10 for 10 is conflicting with the binary number for 2. And this is true with 11 also. So instead of doing that, they just write the letters A, B, C, D, E, and F. So it's not confusing for a computer or for a human to distinguish what is a 2 and what is a 10 in hex. So with this all being said, we get the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. And this makes up our hexadecimal or hex numbering system, which is a base 16. If we wanted to convert the decimal number 398 base 10 into some number in hexadecimal base 16, we would do what's called integer division, and we would divide 16 by 398 with the remainder. So 16 goes into 39 twice, which would give us 32. Subtract those, you get 78. 16 goes into 78 4 times, which would be 64. Divide by 2, or subtract, you get 14. So 398 divided by 16 equals 24 with a remainder of 14. Now we're going to take this 24 and divide that by 16. So 16 goes into 24 one time. We're going to subtract 16. So that's going to be 8. So we're going to get 1 with a remainder of 8. So 24 divided by 16 equals 1 remainder of 8. And then we're going to subtract 16 by 1. We're going to get 0 with a remainder of 1. So 16, or 1 divided by 16 equals 0, remainder 1. Now we're going to read these remainders up, and we're going to get 1, 8, 14, which is going to be E, equals 398 base 10. And if we wanted to go back, we would do E, which is equal to 14. We would do 14 times 16 to the 0 plus 8 times 16 to the 1 plus 1 times 16 to the second. This is going to give us 14. This is going to give us 128. And this is going to give us 256. We're going to add these up, and we are going to get 398. And that's how you go back from hexadecimal to from hexadecimal to decimal. Now, if we wanted to go from binary to hex, this is a lot easier than going from decimal to hex because there's a little trick that we can use. Since hex is 0 through 15, we can write the numbers as binary numbers as 4 bits with 4 bits. So what does this mean? So if we had 0, this is going to be our base 16. This is going to be our base 2. So hex versus binary. So if we had 0 in hex, that would be 0, 0, 0, 0 in binary. If we had 1 in hex, that would be 0, 0, 0, 1. If we had 2, that would be 0, 0, 1, 0. I'm just writing the binary representation for this number. If we had 3, it would be 0, 0, 1, 1. 4 would be 0, 1, 0, 0. 5 would be 0, 1, 0, 1. 6 would be 0, 1, 1, 0. 7 would be 0, 1, 1, 1. 8 1 0 0 0, 9 1 0 0 1, 10 1 0 1 0, 11 1 0 1 1, 12 1 1 0 0, 13 1 1 0 1, 14 1 1 1 0, and 15 finally 1 1 1 1. And this is just the 4-digit binary representation for all these numbers. And that's all you need to know to convert binary to hex. So if we had the binary string of 1 0 1 0 0 0 0 1 0 0 0 0 1 1 1 1, we can split these into 4 groups of 4 and just figure out what the binary representation for all these numbers are. So for this first one, that's equal to 15. So we can write an F, because F is 15 for hexadecimal. This is equal to 0, so we can just write a 0. This is equal to a 1, so we can write a 1, and this is equal to 10, so we can write an A. So 1 0 1 0 0 0 0 1 0 0 0 0 1 1 1 1 is equal to A10F in base 16. And if we wanted to convert this back, we would get, if we wanted to convert a hexadecimal number into a binary number, we could do the number 85A base 16 to something in base 2. We would do 85A and just figure out the 4-length binary number that represents this. So for A, it's going to be 1010 because that equals 10. For 5, it's going to be 0101, and for 8, it's going to be 1000. And then just write this as a full-length string, and we get the binary number. So it's going to be 1000, 0101, 1010. Base 2 equals 85A base 16. And that is how you go from hexadecimal to binary.